All right, so today's lecture is about the debugging tools that are built into R. So these come with R. They're not part of any package. And they can be useful for kind of figuring out what's wrong after you've discovered there's a problem, right? So how do you know that there's a problem? So there are a couple of indications that R will produce that will give you the sense that there's something going on. And this is roughly the gradient. And so I think I mentioned this before, but basically there are three main types of indications. The first is a message. And a message is a very tame notification. It's just it could be a diagnostic message that something happened, but it could be nothing. Okay, and so the message won't stop your function from executing. It will just there'll be a message that gets printed to the screen, and the execution of the function will continue, and that's all. The next level up is the warning. Right, so a warning is another indication. Usually, if you're writing a function and you're trying to figure out, okay, what's a message and what's a warning. Furthermore, or if you're using a function and you're figuring out, well, what does that mean? A warning is an indication that something unexpected happened. It's not necessarily a problem, and many times you explicitly want to ignore warnings, but something unexpected happened. So the function was expecting one thing, and it got something slightly different. It wasn't enough to kill the whole thing. But it was enough to kind of trigger this warning. So execution of the function will continue if a warning occurs, but you'll get a message after the end. So you'll get a message when the function completes execution. So when the function comes back, when you get your console back, that's when the warning appears. So you won't get a warning in the middle of the execution by default. So these are generated by the warning function. Sorry, I should say the messages are generated by the message function. And then an error is the last stop, right? So an error is a fatal problem. This stops execution of the function, and these error messages are produced by the stop function. And then there's a general notion of a condition, which is it's a higher level concept. All three of these things are conditions, and so you can imagine that. So you can create new conditions if you wanted to. So if you have And generally, you're not going to do this at this level, but if you have another type of condition that you want to kind of trigger when a special thing happens, so that's not an error, it's not a warning, and it's not a message, you can create your own conditions and using some of the functions that are available. So we won't be doing that now, but there is this notion of a condition, and it's generic. So this is your basic warning, right? You take the log of a negative number. You can't do that, right? Now, notice that you get a value back. It's a nan, right, not a number. But you also get this warning, which occurred after the execution of the function. And it just says that in the log of -1, nans were produced, right? So this is your typical, and sometimes that's fine. Because maybe you're taking the log of a bunch of numbers, and maybe some of them are negative, but you don't really care. And then you're going to make some sort of plot or something like that. So this is the kind of thing where you probably wouldn't want the function's behavior to just stop any time it sees a negative number, because sometimes these things just happen. You get negative numbers on occasion, and you want to take the log anyway. So that's a warning. Now I've got a little function here that I've created. It's very simple. It takes your input. It checks to see if it's greater than 0. If it's greater than 0, it prints a message saying x is greater than 0. If it's less than or equal to 0, you get a message saying that it's less than or equal to 0. So very handy function I'm sure you'll all be using soon. And then last, I just want to mention this part here. So invisible is a function that stops, or I should say, it prevents auto printing. Right. So normally if I'm at the command line and I type a function, remember, and I execute a function, the function will return the last element that's in its function body, right? So if the last element in its function body is a numeric vector, it will return that numeric vector. Now, what happens is that if you just execute the function, that numeric vector will be automatically printed to the console because it got returned by the function, and R will use auto printing to just print that to the console. If I call invisible on the return object, then it will still return the same object. But it won't do the auto printing. So you can call the function, and the object will be returned, but there won't be any auto printing. So an example of a function like this is the load function. So we haven't really used that much, but the load function loads objects from a saved workspace. So it's like the opposite of save, right? But when it loads the objects, it actually returns a character vector containing the names of all the objects that it loads. But that doesn't get printed to the screen because it's returned invisibly. Okay, so if you have a function that returns something invisibly, then what happens is that the object that gets returned by that function doesn't get printed to the console. And so sometimes you want that to happen, and sometimes you don't. Sometimes it doesn't matter. So here I've just added this here just so I can tell you about it. It's not particularly important. But actually, I should say that any print function here, actually, all print functions will return the string that it prints. Okay, so when you say print x, what gets returned is a string x, right? But you don't actually see that because the return value is returned invisibly, right? So it actually so you could assign the output of print to like an object, but generally speaking, you never do that. So anyway, that was a little diversion on invisible. So here I create my print message function, and I call print message 1. Great, no problem. I get the message x is greater than 0. Okay. So so what does print message return? Just before I go on, print message returns its argument, right? And so actually, if I had assigned the output of print message to some other object, it would be the number 1 in this case, right? Even though it didn't print out the number 1 anywhere. So now I'm going to pass it directly in NA, right? And I'm going to get an error here because you can't make the comparison if NA is greater than 0. It's not defined, right? And so it doesn't know what to do. It can't move on, and so it has to error out. Okay, so you get an error saying that in this expression, if x is greater than 0, the missing value, you have a missing value. So it was expecting true, false, and instead it got NA, which is neither true nor false. Right? Okay. So something happened there that's wrong. Now I'm going to fix this problem, so to speak. I've got a new function, print message 2, and the first thing I'm going to do is I'm going to check to see if the argument's NA. Right? And so now if it's NA, I'm going to print this message, right? So it's not going to produce an error. It's just going to print a different message. So this function is going to print one of 3 messages for now, and then it's going to return its argument invisibly. So when I call this, so what's something that might typically happen? Well, I calculate the log of -1, and I assign it to x. So that doesn't stop anything. I just get a warning, and I move on, right? Now I'm going to print message on x. And I'm getting x as a missing value, right? So now there's no error there, but it may be unexpected, right? Because maybe I thought that, okay, well, the thing that I'm inputting into print message 2 is like some positive number, so I thought I was going to get the message x is greater than 0, but instead I'm getting this message x is a missing value. So what happened, right? And so this is the kind of thing where what you thought you were going to get, where your expectation is different from actually kind of what the function produced, right? And so all I'm trying to say here is, how do you know when something's gone wrong, right? So sometimes it's easy to tell, like in the case where we got the error message, but sometimes it's not easy to tell because here there's no error, but it's not exactly what I was expecting, okay? It's when you're looking at a function, you think something's gone wrong. There's a couple of questions you want to ask yourself to see whether there's something actually is wrong, or there is something that we call user error. Okay, so when you're kind of thinking about when you're debugging a function, you want to answer all these questions as you're going through your process here. So what was the input that you put? What did you feed into that function? Okay, not what you thought you fed into that function. What did you actually feed into that function? Okay, so I thought I'd fed that function a positive number, but in reality I fed it a nan, right? So how did you call the function? What were the arguments that you gave it? Things like that. What were you expecting? And this is important when you're asking someone for help or you're asking someone a question. It's not that useful to say, oh, the print message 2 function didn't work. How do you know it didn't work, right? And then you say, well, I was expecting this, but I got that. Okay, that's how you know it doesn't work. And then someone could say, well, you shouldn't have expected this because that's not what that function does, or something like that. Or they can say, okay, here's the problem. So what were you expecting is very important to be able to articulate at least to yourself and maybe to other people. What was the output that you were expecting? Were you expecting some message that you didn't get, or other results, other numerical results, things like that? So what were you expecting? And then, of course, what did you actually get? How did what you actually get differ from what you were expecting? And then, of course, were your expectations correct in the first place? So if you were expecting something that was in fact incorrect, then your notion of what is correct and incorrect is now being challenged, right? So, and then another key aspect of debugging, of course, is that you have to be able to reproduce the problem, right? Because if you can never reproduce the problem, you'll never have a chance in figuring out what went wrong, because it only happened at one time, right? So, this is very, 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 very important. And unless it's the most basic problem, that I can't even say what that would be, you have to be able to reproduce the problem. Because you have to be able to show someone, this is how I created the problem. Because most people are not going to know if you just show them the output or the error message of what that means or where it came from and how you got there. Okay, so the process by which you encountered the error or the problem is very important. So you have to know how to reproduce the problem. There are some problems, and so when I was talking about, for example, in random number generation, you need to set the seed, because it may be that only under a certain sequence of random numbers that a problem occurs. And if you're not setting the seed, you will never be able to reproduce that problem, because every time you run it, it's going to be a different set of random numbers. There are other types of problems that can be hard to reproduce, but they're more complex. They usually, for example, if you're writing networking functions, something, so you're doing like parallel programming, often those kinds of problems can be very hard to reproduce because they depend on activity in other machines and things like that, and you can't really reproduce that. Things that if you're getting code over the internet, if you're getting data over the internet and your code is kind of interacting with things on the web, problems there can sometimes be hard to reproduce because servers on the other side may change or whatever, and so so you can't always freeze things in time. If there's something that's just happening on your computer, it's usually going to be easier to reproduce the problems. So only under very esoteric circumstances will it be hard to reproduce a problem on your computer.